What's up, guys? Now I'm back with the video. This is a second take of this video that I just tried to record. I'm recording this with an iPhone and I actually ran out of space on the phone, so I'm gonna have to restart this entire test over again. I've had some people reach out and they want to see Cinebench R20 testing, and I've kind of done some research on my own just to kind of see where the Intel 10th gen parts kind of plot against Ryzen 7nm parts. As far as efficiency, and I'm finding that with an undervolt, they're almost 1-to-1, like super close in efficiency, with the Intel part obviously being faster at gaming, and then if you have access to XTU in a laptop that can cool it, you're going to be able to get obviously higher performance out of the Intel part, even in multi-core rendering and applications that are going to take advantage of that. Again, that is going to be contingent upon being able to use XTU or throttle stop. And then having the cooling capability in your laptop, just because they can overclock, they can undervolt, and then you can kind of go in and tweak and tune them dependent upon your own individual chip. So the first test we're going to do is we're actually just going to do 45 watts, which is the Intel quote unquote spec for their power limit. Now, the way Intel rates their power limits is actually at base clock. So 45 watts isn't actually the max that it can be allowed to go to. There would obviously be a PL2 in there, power limit that it could go to. I don't know what that is. Intel doesn't publish these power limits. They just establish that there is a PL1, PL2, and then they kind of leave it up to, it seems like, the laptop manufacturers to do what they want. Now with the MSI laptop here, this GP66, when I install XTU, it defaults to 200 watts on both PL1, PL2. So MSI isn't enforcing, it seems like, from what I'm finding on mine, and it may be a mistake, but it just defaults to 200 watts on both, and it then just kind of controls temperatures by, once it hits 95 degrees Celsius, it brings the clocks down, and it does a really good job. It doesn't go above that. I haven't seen it go above 96 degrees Celsius, and it will then thermal throttle itself to maintain within that envelope. So it's kind of cool to see that, and then you can obviously use XTU yourself or throttle stop. If that, I haven't tested throttle stop myself, but I'm assuming they'll be updated to work with Ice Lake Tiger Lake H45, and then you can tune with that as well. Some people prefer throttle stop over XTU, or you could do it in the BIOS if you wish to do that. So first test, we'll do 45. It is on stock clocks. I'm going to set the voltage offset to 0, so no undervolting will be done for the first test. And I am in non-discrete mode on the GPU, so that's why the graphics tab is back. I finally figured out why it obviously is showing. You have to also set the cache, because the cache and the core are not tied together. The GPU and the core undervolt are tied together. So 0 and 0, stock clocks, 45 watts on the power limits. We'll open up hardware info 64, because every time you make a change, you have to recycle the program to see it actually take effect. It will actually still take effect, it just won't refresh in the window for you here, so you won't be able to see it. So 45 on both PL1, PL2. So this, in my opinion, is kind of a not stock config for the laptop. You're actually clamping down power limits, which would not be the default state that you would get the laptop from MSI. And then you can see there's no undervolt here on the core cache or the GPU or anything like that. We'll leave the fans at auto, and we're gonna run it. So what you are gonna see is that the laptop's gonna pull 45 watts like we told it to do, and it's gonna go right up to 45 watts, and because it's only 45 watts, it's not gonna be able to obviously maintain 42X on all 8 cores, which would be the default all-core turbo. And that is because we are going to be power limit exceeded, yes, and then you can see down here, package power is at 44.8, so it's riding right up to that power limit. Fans at auto, you can't hear them running, because for this laptop, even with its stock thermal paste, conventional thermal paste, not liquid metal, it has no problem cooling 45 watts of power. So we'll go through this test, and then we're gonna run up against some higher tests, some higher power limits, and kind of figure out where, I'll give you my opinion where I think it's gonna be the best for most people if they're doing multi-core rendering and stuff like that, kind of how to tune it, and in my opinion, what the best, for at least for my chip, and these chips aren't gonna vary that much in silicon quality, what is gonna be kind of the best clocks, undervolt, and power limit that you may wanna set. And with XTU, you can go in and you can set profiles and save them so that you don't have to do this every single time. You can just click on the profile you want. So you could have one for gaming, which may have an overclock or higher clocks, higher power limits. And then you could have one for like multi-core rendering or something like that, professional work, which is at stock with an undervolt and lower power limits, so you can control the temperatures under 100% load. 3495, so almost 3,500 points, just at 45 watts. Fans basically were inaudible the entirety of the test. We peaked at 66 degrees Celsius on one, so it was 63, 63, 64, 66, 65, 62. So really, really thermally efficient machine. Does a really good job. If you were just to leave this at 45 watts, you could hammer it all day long with 100% load and get pretty good performance out of it. Again, this is kind of the non-default state. I'm not going to bother doing a test with max fans just in the interest of saving time, because it didn't thermal throttle. It's not really going to make a huge difference to the performance. So I've compared this laptop and I've done some research on my own, kind of against 5900HX in a Strix 15. Now the 5900HX is obviously a binned part. It's one of the highest parts from AMD. It's not meant to directly compete with just the base i7 1100H. That would be more reserved for something like the 11.9 or the 11.980HK. So we're just gonna see though, can we get this thing to match AMD's highest R9 part for laptops with Intel's lowest binned i7 8-core part. So kind of the lowest binned 8-core from Intel versus kind of the highest binned 8-core from AMD. Now I don't know if that is the highest part, but that's the highest part I've been able to find anything online about. So, and I think the HX means it's supposed to be overclockable. At least that's the way that AMD was advertising it, at least from the slides I saw. But they did have a footnote that it was going to be dependent upon manufacturer, but I haven't seen a single laptop from AMD that they've allowed any sort of tuning or overclocking or undervolting or anything like that. So because it's available on Intel, I am going to use it because it's kind of fair game. If it's available on Intel, then definitely you should be able to use it. And I think most people will go through and undervolt and tune. And then if they have access to XTU and overclocking, they're obviously going to do that as well. So the next test we're going to do is we'll bump it up to 65 watts. On both the long and the short. So 65 watts on both, and we will not apply an undervolt. We'll open up Hardware Info 64 again, and we're going to run the test again. Same auto fans. So we haven't modified the fans. They're just going to run auto. There's no undervolt. 42X, it's not going to be able to sustain that with just 65 watts of power. It is going to start to throttle itself down. Temperatures are obviously going to go higher because now we're pumping 65 watts of power through the CPU for sustained power draw, and we're on auto fans. Fans are ramping themselves up a little bit to cool the chip, and you can see 65 watts there of sustained power with no undervolt, and it's just going to hold 65 watts for the entirety of the test, and then throttle itself. Power throttle, because it's not thermal throttling yet, right? We're only peak of 82 with most of the cores in the 70s. Again, with auto fans, this is totally sustainable. If you didn't want to ramp up your fans to max power to get every last bit of thermal efficiency out of it, you could leave these things at the auto and they would be decently quiet, not super annoying if you were in somewhere that may be more sound sensitive. So 42, 46, not too bad. For 65 watts, we peaked at 84 degrees Celsius, no undervolt, nothing like that, 84 degrees Celsius. So now we're gonna go ahead and restart the same test at just 65 watts with an undervolt. Now, negative 70 millivolts is pretty, I would say is probably what you're gonna expect on even the worst of chips. I don't think I won the Silicon Lottery with this, so you can see it applies it to the graphics as well, but that doesn't make a difference. The core and the cache are what we're most interested in. Again, we'll keep it at 65 watts. We'll close out of XTU. We'll open up Hardware Info 64 again. 42, 46 was the score, 84 degrees Celsius on the previous test. And you guys can see right there is -70 across the board with 65, 65. Same auto fan profile. We're not gonna mess with that. I'm gonna let it see what it can do. The temperature should improve just a little bit, but what we're actually going to see is that it's going to be able to maintain and sustain higher clock speeds throughout the test, because now we're giving it just a little bit more room within that 65 watt power envelope where it can maintain higher boost clocks throughout the entirety of the test without having to throttle down on the core clocks as much to stay within that 65 watt limit that we're imposing on it. So we're still up to 84 degrees Celsius. Auto fans, they're there, but they're not, not cranking. It's doing a much better job as well of kind of pushing up to that 42x max that we have default out of box. And 4751, so just on auto fans, no liquid metal, with an undervolt at stock clocks and in 65 watts clamped down, it's scoring 4751. Now, I compared this against the 5900HX, which is a binned part from AMD. So this CPU would be more comparable to the 5800H, which isn't as binned at all. So it's going to require more voltage, and which is going to lead to a higher power draw to achieve the same scores compared to the 5900HX. Watching Gizmo Sliptek's video, went their Strix 15, so a 15-inch laptop. It's got liquid metal on it. He was running max fans, 86 watts sustained in the video. You guys can watch this in their live benchmark video. 86 degrees Celsius, again, that's with liquid metal and max fans. 5,100 points in CB20. This was 65 watts. Liquid metal is not applied to this, just crappy stock thermal paste. And we only pulled 65 watts. Now, of course, we used an undervolt, but we also used idle fans or auto fans, and 21 watts less of power, and we didn't score that much lower. And he was averaging about 51. One run was above, one run was a little bit below 5,100, so about 5,100 points on that laptop. Both similar probably in size. The Strix 15 is a larger gaming laptop, and I pulled 21 watts additional power to achieve about 300 points, 350 more points. So not a huge difference in efficiency between the two chips. So what we're going to do is we're going to pump it up to 75 watts now. So we'll leave the 70 undervolt. And instead of 65, we're going to go to 75 watts. So 75 on the short and the long-term power, so still less than what they're using on that CPU that I saw. And we're going to use max fans on this one. Just because 75 watts, it's definitely going to get a little bit warmer. 75 watts sustained power. So it's kind of fair. Everybody's using max fans for this test. So there's max fans. We'll scroll down and show you really quickly. -70 and 75 and 75. So we're going to go ahead and start the test. So it should be able to sustain 42 just a little bit better now, because we're allowing it 75 watts of power. It dipped to 41 there, back up to 42. Temperatures are peaking in the mid 70s to very low 80, 81 degrees Celsius. It's up to 83. And this, in my opinion, is pretty much where I would say I would keep the laptop maxed out. 75 watts sustained power is going to keep you kind of in the mid 80s on most of the cores with that undervolt and give you really good performance. If you were to apply liquid metal, you could definitely, or better thermal paste than whatever is stock, you could definitely push that envelope a little bit more, but I think this is going to be a nice safe envelope for most of you. All right, so 5192. So we've already beat what they were showing for the 5900HX, and we actually drew 11 watts less of sustained power. So you guys can come down here, you can see 75 watts was the peak, and again, it's gonna sustain that through the entirety of the test. And we scored 5192, so we've already beat out what you're gonna see on a 5900HX with less power, without liquid metal, and in the similar size chassis. So my opinion is that the 10nm process is very comparable. Of course, it did require an undervolt to achieve that, but it's very comparable in terms of efficiency, as long as you're gonna have access to the undervolt. So we'll do one more test. We'll actually remove the undervolt and kind of see how close it's going to be in terms of efficiency. So I actually haven't tested that myself, but yeah, 5,200 points, clamping at 75 watts. We didn't thermal throttle, we didn't hit 90 degrees Celsius. And we'll set that to 0. So 0 across the board, 75 watts. And we'll reopen hardware for 64 just to show you that that did take, and apply. So 0, 75 watts maxed out. That's the max it's going to be able to pull. 5192 with the previous with the undervolt. It's going to ride right up to that 75 in just a second. There it is, 74.298. So it's actually staying under 75 watts. It's going to get warmer because we don't have an undervolt, and the core clocks are not going to be able to sustain as high, again, because now it's going to be limited first by power, later probably by temperatures. But we'll see. 81's the peak temperature right now on that hot core, with the rest in the mid 70s. Again, still 74.9 watts. So actually it didn't change anything. 5192, so the undervolt, it seems in that situation did absolutely nothing in terms of, which is really surprising. It seems like the boost did a really good job of just kind of taking care of itself there. Wow, that's actually really surprising. That was not expected. Peak temperature 89 degrees Celsius at 75 watts. No undervolt was applied. We actually outscored the 5900HX, pulling 86 watts. And again, if you want to compare, go ahead and watch Gizmo Slip Tech 5900HX Strix 15 video, where he shows 86 watts of sustained power pull, 86 degrees Celsius with liquid metal max fans, scoring about the same or just under this score, and pulling 10 watts of additional power. So it seems the AMD part is more efficient on the lower end, where Rocket Lake, as long as you can, Rocket Lake, Tiger Lake H, yeah, right, Rocket Lake, absolutely lava lake. I have one, and it draws just insane power. It's nuts. It seems like the Tiger Lake part really scales well with power, and it kind of gains performance and efficiency, or starts to outscale, I guess, the AMD part at the higher end. If we were to clamp these both at 45 watts, AMD absolutely destroys the Intel part, but because both of these laptops allow you to pull more power, if you were to compare which one is going to give you better performance multi-core, it seems like it's going to be about the same. It doesn't really matter. The Intel part scored about the same, but actually pulled 10 watts less of power. So I don't think that either way you can go wrong. I think they're both going to be, efficiency-wise, they're very, very, very similar. I don't think that you guys are going to have any problems either way. I think the Intel part's going to be faster for gaming. 10th gen was already faster. Intel's 11th gen is even better. So esport titles like CSGO, Valorant, Overwatch, things like that, you're going to get better performance on the Intel part. Multi-core performance for rendering, things like that, I don't think it's going to matter. It's just going to be a toss-up. So I think that go with whatever laptop you like better. and whatever one suits your needs. I don't think it's going to matter either way which CPU you really pick, unless you're looking at it purely for gaming. I think that Intel is just, it's going to be a better gaming CPU. So it's going to come down to, what do you need? Do you need Thunderbolt? Do you need PCI Express 4.0? Do you want better gaming performance? For me, I would be leaning towards getting the Intel part. If you want to save a little bit of money and you don't need Thunderbolt 4, like for example, this thing doesn't even have USB-C, then you could save a couple $100 depending on how much the AMD part is going to be. I don't know how they shake out yet as far as specs and price. If it is a couple $100 savings, maybe that's going to be important to some people, and they may sacrifice some gaming performance for it. So that's about it, guys. That's what I wanted to show in this video. Really good performance. 10 nanometer is super efficient. 75 watts of power, and we're getting that score is absolutely, it's really, really good. And temperatures are completely controllable, and that is without even undervolting. So I hope this was useful to some of you out there that want to see Cinebench R20. It seems to be a more common test that people like to see. I'm going to get this video uploaded, and then I'm going to do some more game tests. I'm looking at Rainbow Six Siege, Far Cry 5, and then Battlefield V, because those are some games that I do play. All right, guys, I'll catch you in the next one.